Here, this is our test platform. We're doing 2 axis of movement, 6 degrees in azimuth, and then 3 degrees per second in elevation. This is meant to simulate motion, not only of the local platform, but also as if the target was actually laterally moving across the horizon. Generally, if you're 5K, about 1 degree a second is, 50, 60 miles an hour. So that's kind of, where we've tried to get our performance to. And just real quick, it's snowing, but I'll pop this off so that you get a feel for actually what's happening inside this guy. But you can see, obviously, that the base is moving quite a bit more than the antenna. The antenna almost looks stationary. It looks stabilized as this thing twists around and moves on its base. Then that's really where the stabilization kicks in and keeps it on target. But that's really what you're looking at. You can notice in there also the GPS internalized.
Right.
It gives us, again, more environmental control and also avoids snow buildup and water and those sort of things, which can attenuate the GPS signal and that sort of thing.
So right now we're doing 5 degrees per second.
Yeah, we're doing 6 in yaw and 3 in pitch.
3 in the pitch.
Yep. And you'll notice, we're limited on this test. It's actually moving 100 plus or minus 180 degrees. So at the direction change point, it's obviously somewhat of an inaccurate test because your ship's not going to, flip around and start moving the other direction instantly. But you'll even notice here in another 10 seconds, it is going to get to that point where it flips around. So you'll see a little bit of drag, and this will really demonstrate, I think, the speed that the stabilization can actually switch gears and go the opposite way. So probably the harshest part of the test is right here. So now you'll notice that it goes the other way, has to make a motion back in the opposite direction, and now it's back into its just stabilized mode again.
Now you said 60 mile an hour is equivalent to 1 degree per second.
I got a chart inside. I was kind of pulling that from memory.
Okay.
But I definitely have a chart inside. I think 1 degree a second of lateral movement at 5 kilometers comes up to be like 45 miles an hour, somewhere along those lines. We'll go back inside and look at that chart, and I'll tell you for sure, but that's kind of what you're dealing with.
And this is the Motorola PTP 600?
This is the 600. Yep. One of the better radios.
What's your beam width on this antenna?
8 degrees.
8 degrees beam width.
8 degrees, yeah.
And we're shooting to the remote site that's how far?
That is about 300 feet. It's 0.13 kilometers based on the GPS differential.
Okay.
What we're looking at. And the other side actually at current